Okay, Assalamualaikum and hello everyone. So today we are going to learn how to predict shapes of molecules, right? So you're given a molecule, okay, and then dia nak suruh awak predict the shape. So we are going to use VSEPR theory. But there are 6 steps that you have to apply, okay, to your molecule in order to get your correct molecular shape. Okay, so the first step is for you to draw the Lewis structure. So you have to get this one right, okay? And then from your Lewis structure, you will determine the number of electron pairs that are around your central atom. Alright? So from there, awak tahu berapa the number of electron pairs. Okay? So the shape is dictated by the sigma bond framework. Okay, meaning you will treat single, double, triple bond sama je. Maksudnya molecular shape tu, even though it's like this, CO2, okay, awak akan nampak dia as a linear shape saja. Okay, awak akan nampak dia as macam ni. Okay, the shape. The sigma framework saja. Maksudnya single bond saja yang awak akan nampak. Third step is for you to determine the electron pair arrangement. Okay, so once we have the number of electron pairs, you can know which basic molecular shape your molecule is based on. Okay, so I can tulis based on what basic molecular shape. Alright, and then write down the number of bonding pairs and the number of lone pairs that are around your central atom. Okay, so why do we need this? Because we want to get the fourth step, which is to state the class of your molecule. If it has a one bonding pair, maksudnya dia AB saja. Okay, if it has two bonding pairs and one lone pair, maksudnya dia AB2L. Okay, atau E, tak kisahlah. Alright, so that is the class of your molecule. So from your class of molecule nanti, you will know what shape of molecule you will get. Okay, step 5, you must apply the VSEPR theory onto your molecule. Okay, now that you know whether it has kalau dia ada lone pair, then you must explain the position of your lone pair specifically for these apa ni, two basic molecular shapes. Kalau dia based on trigonal bipyramidal atau octahedral, then you might want to explain the position of your lone pair. Is it axial or equatorial position? Okay, octahedral actually tak kisah sangat lah, tapi selalunya dia akan sit at opposite axial positions, the lone pairs. Okay, for trigonal bipyramidal, your lone pairs usually will sit at the equatorial position. Okay, under VSEPR theory, okay, more importantly, you will explain the effect of electron pair repulsions, okay, towards your bonds, okay, whether kalau ada lone pair, kalau ada lone pair bonding pair repulsion, bonding pair repulsion, lone pair bonding pair repulsion, okay, you have to compare the strength of repulsion between those electron pairs. Okay, what will it do to the bonds? Okay, your bonds will be pushed closer together. So what will happen? Then the bond angles between your bonds will be smaller compared to your basic shape selalunya. Okay, bila dia ada lone pair. Alright, so finally you must draw the shape of your molecule. So this one you have to get it right and show the bond angle, okay, between your bonds lah. Okay, bagi tahu ini berapa degree, 90 degree ke apa-apa. Alright, okay, so let's head on to our 3 examples. So the question asks you to use the VSEPR model to predict the shape of the following molecules. So we have these 3 molecules and we will I will explain one by one how you get to the molecular shape. Okay, so we are going to apply the 6 steps. Okay, so first of all, we will start with CCl4. Okay, CCl4, first you have to get your Lewis structure right. So macam biasa, you will write the valence electrons and then does it have any charge and total up the number of valence electrons. So 32 electrons, meaning you have 16 electron pairs. So those 16 electron pairs, how are we going to distribute it around your CCl4 molecule? So first you will start with carbon, okay, and then you know that it is more electropositive. That means that it will be your central atom, and then you write down your chlorine molecules around it, okay. So and then you will put your bonds, okay, 1, 2, 3, 4. So from there we know that we will use 4 of the electron pairs as the bonding pairs. So you have 4 bonding pairs here. So you are left with 12 lone pairs. Now these 12 lone pairs will be used to octet the terminal atoms, okay, meaning Cl. So you can see here that I already octet my terminal atoms. All my chlorine has been octet, 8 electrons around it, okay. So check your formal charges, okay. You will check that it will all have 0 formal charge. So that is your most plausible Lewis structure. So once you get your Lewis structure right, you are going to use that as a guide to know the number of electron pairs around your central atom. Your central atom is carbon. So if you look here, okay, your carbon here, it has 1, 2, 3, 4 bonding pairs. 4 bonds around it. Does it have any lone pair? No, okay. So if it has no lone pairs, that means you have 4 electron pairs around your carbon. Okay. Now that we got to number 2, we're going to continue to number 3. Okay. Number 3, you must tell the electron pair arrangement of your molecule. So the electron pair arrangement of CCl4 is based on what basic molecular shape? So if you have 4 electron pairs, that means that this is based on tetrahedral shape. Okay. So you're going to write the electron pair arrangement. Okay. And then you write down how many bonding pairs around carbon. You know that you have 4 bonding pairs around carbon. And how many lone pairs around carbon? Do we have any? Do we have any lone pairs? No. Okay, so 0. Okay, next we want to write the class of our molecule. Since we already know we have 4 bonds and 0 lone pairs, that means that the class of molecule will be AB4. Alright? So dari sini juga, daripada class of molecule, you already know what shape is your molecule. So it will be tetrahedral. Alright? Okay, so before that, we want to use VSEPR theory to explain our bond angles, okay? Our repulsion between our electron pairs. Okay, since, okay, for CCl4, okay, if you look here, dia hanya ada bonding pairs around carbon, alright? And we know that it will be based on tetrahedral shape. Maksudnya kita punya tetrahedral shape akan jadi macam ni. 1, 2, 3, 4. Okay, 4 bond. Alright, since it's all 4 bonds, tak ada lone pair, that means that our bonds, okay, dia all our electron pairs, all 4 of our electron pairs will be bonding pairs. Okay, therefore the repulsion of bonding pair electrons are equal. Okay, sebab semua bonding pair repulsion saja. Bonding pair repulsion only. Okay, tak ada lone pair bonding pair. Okay, tak ada repulsion lain. Alright, so maksudnya kita akan take account of bonding pair repulsion saja dalam awak punya molecule. Okay, so this is the explanation, and then you are going to talk about your bond angle. Alright, so bond angle of your Cl carbon Cl bond angle, maksudnya this bond angle. Okay, so the bond angle will be 109.5 degree because we don't have any lone pairs. Okay, so the bond angle sama seperti your basic molecular shape tetrahedral. Alright, so finally step 6, you are going to write down the molecular shape. It is tetrahedral, and draw your molecule. Okay, so when you're drawing your molecule, make sure, okay, untuk tetrahedral, dia punya shape macam kaki ayam. Okay, kaki ayam. And then you are going to write down the bond angle 109.5 degree. You can write it here juga 109.5 degree, kat sini boleh, semua sama, alright? Okay, so that is your CCl4 molecule. Next, we are going to look at SEF4 molecule pula. Okay, so I'm going to go fast. On the Lewis structure, you already know how to draw your Lewis structure. Okay, and if you look here around your selenium, we are going to count the number of electron pairs around selenium. Okay, so look at your Lewis structure. Ni selenium. So ada apa around dia? Ada 1, 2, 3, 4 bonding pairs and you have 1 lone pair. So maksudnya kita ada 1, 2, 3, 4, 5 electron pairs around selenium. So write down 5. Okay. So from the number of electron pairs around your central atom, you know the electron pair arrangement will be based on what basic molecular shape? It will be based on trigonal bipyramidal. Okay, so I'm going to make this smaller because I don't like the tulisan to be so terkeluar. Resize. Astaga, boleh lah tu. Okay. Alright. So, after that, okay, we are going to write down the number of bonding pairs around selenium. So you know that you have 1, 2, 3, 4 bonding pairs. So write down 4. And lone pair, you only have 1. Okay, 1 lone pair around selenium. Selenium tau, bukannya awak punya terminal atom, bukannya the whole molecule, right? Awak nak tengok dekat central atom awak je untuk step number 3 ni. Okay, so after that, okay, we are going to look at the class of molecule. Once we have this, we can easily write A, B, 4, L. Okay, L2, 1 lone pair. Alright, so from there, you can actually refer to your table in the notes, okay, to get the shape of your molecule. Okay, so from here, we are going to explain using valence shell electron pair repulsion theory. So this is important. You must compare the electron pair repulsions, okay, that are available, that are in your molecule. Okay, so if you look at your Lewis structure, your selenium, it has bonding pair and also at least 1 lone pair. So since dia ada 1 lone pair, maksudnya we will have lone pair bonding pair repulsion lah. Okay, so you must compare this to what other repulsion do you have? You have bonding pairs kan? So maksudnya between ni ada repulsion juga. Okay, you're going to talk about bonding pair, repulsion. So just compare between these two, the strength of repulsion. Okay, so here we can write, ni patutnya tulis repulsion strength of, okay, we know that bonding pair, lone pair repulsion is stronger than bonding pair, electrons repulsion. Okay, maksudnya this repulsion of lone pair and bonding pair is much bigger, much stronger than the bonding pair, repulsion between the bonds. Okay, so from here, okay, we can conclude that the selenium fluorine bonds, okay, these bonds are pushed closer together. Okay, because yang ni akan tolak kan dengan bond kan, dia akan tolak. So maksudnya these bonds 1, 2, 3, 4 bonds ni will be pushed closer together. Okay, so write that down. Later you can conclude that the bond angle, what happened to the bond angle? Okay, will it be equal to 90 degree and equal to 120 degree like the normal trigonal bipyramidal? No, okay. So your bond angles will be smaller lah. Okay, since you already have repulsions. Okay, so write down this. Okay, the bond angle of your axial fluorine, selenium, and equatorial fluorine will be less than 90 degree. Okay, ini pula equatorial fluorine, selenium, equatorial fluorine, it is less than 120 degree. Okay, so how does that look like in your molecule? Okay, let me show you how do we draw our molecular shape. Okay, first you start off, kalau awak lupa, kalau awak blur, you will start off with your electron pair arrangement ni. Dia based on apa? Trigonal by pyramidal. So you start with drawing trigonal by pyramidal, okay? So kita akan ada central atom, selenium. Lepas tu kalau trigonal by pyramidal, kita ada axial, kita ada equatorial. Okay? So, you have 4 fluorines and 1 lone pair. Where does your lone pair sit at? Your lone pair will sit at the equatorial position. Okay, so pilihlah antara 1, 2, 3 ni. I will pick this one here because that will be easier to draw. I'm going to put my lone pair here. Okay, right, so now that I put my lone pair, I can put my fluorines. Okay, now that we have our fluorines, okay, 4 fluorines, we can show the bond angles. We must show the bond angles. Okay, so fluorine, selenium, fluorine, axial position and equatorial. Look at sini. This will be less than less than 90 degree. Okay, and this one between equatorial bonds, okay, it will be less than 120 degree. So your equatorial bonds will be this one, these two. So maksudnya awak boleh tunjuklah kat sini, less than 120 degree. Okay, so that is your bond angle. The shape of your molecule will be called distorted tetrahedron ataupun seesaw. Alright, so if you look here, macam dalam video saya cakap, dia macam seesaw. Nampak tak? Seesaw, dia boleh jongkit-jongkit. Alright, so the bond angles is smaller than normal trigonal bipyramidal because we have this lone pair here. Lone pair repulsion tu dia tolak the bond angles closer to each other. So the bond angles jadi makin kecil. Alright, so that is how you predict the molecular shape for SeF4. Finally, we are going to look at the molecule xenon F4. Alright, so macam biasa, you start with Lewis structure, and here is the Lewis structure. If you look closely at your xenon, you have 2 lone pairs and 1, 2, 3, 4 bonding pairs. Okay, so write that down. The number of your electron pairs around xenon will be 1, 2, 3, 4, 5, 6. So you have 6 electron pairs. So the electron pair arrangement will be based on what shape? It is octahedral shape. Okay, alright. Then the number of bonding pairs around xenon will be 4. Okay, and 1, 2, 3, 4. And number of lone pairs will be 2. Okay, so write down 2. Oopsie. Write down 2. And then write down the class of molecule AB4L2. Okay? Alright, now that we got that, okay, meaning we have 2 lone pairs around our central atom. So where do we put it? Since it's octahedral, we'll put it at the axial positions to each other. Alright, so next, the valence shell electron pair repulsion theory. Okay, we will talk about the electron pair repulsions that are available. Okay, so we find that we have 2 lone pairs, 1, 2. So that means that we can compare the strength of lone pair electrons repulsion with the bonding pair lone pair repulsion yang ni dengan yang ni. Okay, that repulsion. And also finally, bonding pair electrons repulsion. Maksudnya yang ni. Okay, between these. Okay, so just write down the what happened? What happened, guys? Sorry. Okay, write down. Okay, ini. Okay, write down the order of strength. Alright, siapa paling kuat? Maksudnya lone pair. Electrons ni akan push the bonds down closer to each other. Okay, atau dan kita akan letak our two lone pairs of electrons at the axial position to each other. Okay, maksudnya kan kita ada selenium 1, 2, 3, 4, 5, 6. Okay, your lone pairs will sit axial to each other. Okay, so when you have your lone pairs here, what will happen to the 4 bonds here? It will actually form a square planar shape. Alright. Okay, so the bond angle for your molecule, okay, fluorine, xenon, fluorine will be 90 degree because you have square planar shape. Okay, so the molecular shape will be square planar, and you will draw your molecular shape like so. Okay, xenon. Okay, atas plane tu ada lone pair, bawah plane ada lone pair. So ini adalah plane awak. Alright, the fluorines are sitting at the vertices right here. Okay, make sure to show the bond angle, which is 90 degree for your square planar shape. Alright, so that is for xenon F4. I think you can do your question number 2 in 4.2 tutorial. Okay, and we will discuss it soon. Thank you.